Okay, imagine this. You're a network admin, right? You're staring at your monitor, and some really cryptic error message pops up, demands your attention.
Happens all the time.
Exactly. Maybe it's a VPN that just refuses to connect, or, web traffic is acting really weird. In those moments, what's your first thought? How do you actually get to the root of the problem quickly?
Yeah, how do you cut through the noise?
Well, welcome to the deep dive. Today, we're taking a really close look at practical insights from the FortiGate FCSS NSTSC 7.6 certification exam. And look, this isn't just about prepping for a test.
Not at all.
It's about understanding these, critical network security and troubleshooting concepts that you can actually use day to day in FortiGate environments, real world stuff.
Right. And our source material for this, this deep dive today is basically a selection of practice questions. Good ones with detailed explanations straight from that FCSS and NSTSE 7.6 exam prep.
Think of them as little condensed real world challenges.
Exactly. Mini case studies, almost. They're, great learning opportunities.
So our mission today is pretty clear. Unpack these questions, pull out the really valuable bits of knowledge, and, give you a shortcut to being properly informed on key FortiGate functions.
We're covering quite a bit. VPNs, SSL inspection.
Yeah, VPN troubleshooting, SSL deep dives, system diagnostics, the works, and just for context, remember the exam itself is web-based, 75 minutes, 40 multiple-choice questions, all focused on FortiOS 7.6.
Sets the stage.
It does. It really highlights the kind of practical, hands-on knowledge we're digging into right now. Okay, so let's unpack this first scenario. It's a classic for anyone who's wrestled with VPNs. You've got an IPsec VPN issue, and the diagnostic output flat out says, no proposal chosen.
Yes, the dreaded no proposal chosen.
What does that actually mean? Why is it telling you that specifically?
Well, that message, and you usually see it when you run a diagnose debug application like Migas 1, it's FortiGate basically shouting at you that your phase 1 settings don't match.
Phase 1 settings, you mean like encryption, authentication?
Exactly. The IKE phase 1 proposals, which include, the encryption algorithm, the hashing algorithm, the authentication method, Diffie-Hellman group, all that stuff, the proposals offered by your FortiGate and the one offered by the other end, the remote peer, they just don't have a common set they can agree on.
So there's no overlap at all?
Zero overlap. And without that agreement, that perfect match on a set of parameters, the VPN negotiation just stops dead in its tracks. It can't even start phase 1 properly.
Right. It's like trying to have a conversation where you both insist on speaking different languages.
Perfect analogy.
Yeah.
Nothing gets communicated.
So, okay, it's super specific then. It points you directly at that phase 1 configuration mismatch. Check your encryption, check your hashing, authentication, DH group, lifetimes maybe.
Precisely. It saves a ton of time because you know exactly where the problem lies. It's a fundamental negotiation failure.
That makes sense. It really forces you to be meticulous right from the start. Okay, so given that error points to a negotiation failure, how do you actually see that negotiation? What's happening, on the wire?
Good question. Because sometimes you need proof, right?
Right.
Or you need to see what is being offered.
Yeah, exactly. What tools let us watch that happen?
Well, that's where the built-in packet sniffer comes in.
Yep.
It's incredibly useful. For IPsec, there are two main filters you really need to know.
Okay.
First, to see the IKE negotiation itself, that phase 1 back and forth, you filter for UDP port 500.
UDP 500.
And that'll show you the IKE packets being exchanged. You can literally see the proposals being sent, see if the other side responds, what it responds with. It's essential for diagnosing that no proposal chosen issue.
Got it. And the second one?
The second one catches people out sometimes. It's for traffic that's using NAT traversal, or NAT-T.
When the VPN has to go through a NAT device.
Exactly. When that happens, the actual encrypted data, the ES-key packets, get wrapped up inside UDP packets, and those use port 4500. So to capture that NAT-T encapsulated IPsec traffic, you need to filter using UDP port 4500.
UDP 4500. Okay, that's a key distinction. So 500 for the control plane, the IKE negotiation, and 4500 for the data plane if NAT-T is involved.
You got it. Using those filters gives you that concrete visibility. You can see if the packets are even flowing, if the proposals are mismatched, or if something else is blocking the traffic before negotiation even completes.
That's powerful. It really takes the guesswork out of it. You move from assumptions to actually observing the handshake, or lack thereof. All right, let's shift gears a bit. Moving away from VPNs, let's talk about web traffic and SSL deep inspection, another critical security feature.
Absolutely. Inspecting that encrypted traffic is key.
So we know FortiGate can decrypt and inspect HTTPS traffic, but what happens when there's a mismatch with the website certificate? Let's say the name the browser asks for, the SNI, doesn't actually match the name on the certificate, the common name, or any subject alternative names.
That's a really interesting and important scenario. It touches on FortiGate's core security stance. So if FortiGate is doing SSL deep inspection, and it sees that the server name indication, the SNI from the client, doesn't match the CN or any SN in the server's certificate, well, by default, FortiGate will just block the connection.
It just stops it cold.
Stops it cold. It treats that mismatch as a serious certificate validation failure. And the thinking behind it is protection. It's a safeguard against potential man-in-the-middle attacks, spoofing, or even just badly misconfigured servers that might pose a risk.
Okay, so the default is block first, ask questions later,
It's
essentially.
like, shh, security is the priority.
How does that strict default play out in the real world for admins? Does it cause headaches with legitimate sites that maybe just have slightly off certificates? Or is that strictness generally seen as the right call?
It's definitely a balance. Yes, it can occasionally block access to a site that's technically legitimate but has a poorly configured certificate. You might have an internal server where someone messed up the CN, for instance.
Right.
But FortiGate's philosophy here is, well, security by default. It prioritizes validating that certificate chain rigorously. It forces you to be sure about the identity of the server you're connecting to. The idea is to prevent users from connecting to sites with invalid or potentially malicious certificates, rather than allowing sloppy certificate practices.
So it sets a high bar for trust. You can create exceptions if you absolutely need to.
Oh, absolutely. You have
Yeah.
granular control. You can create exemptions or adjust the validation settings, but the default is designed to be secure out of the box.
Makes sense. Better safe than sorry, especially with encrypted traffic. Okay, let's look beyond inspecting traffic between users and the internet. What about communication between FortiGate devices themselves, like in the security fabric?
Yeah, the security fabric relies heavily on that inter-device communication.
So what does it mean if an admin checks the security fabric status and sees that a FortiGate's FortiTelemetry service is showing link down?
That link down status for FortiTelemetry is almost always pointing to one thing. The physical connection between the FortiGates involved is down.
Physical, like the cable.
Exactly. Or the switch port, or the interface itself. FortiTelemetry is the protocol they use to talk to each other within the fabric, exchange threat intelligence, sync configurations, all that. If the status says link down, it means the underlying physical link isn't active. It's generally not a software bug or a policy misconfiguration causing that specific status. It's layer 1 or layer 2.
That's a really critical distinction, isn't it?
Hugely important for troubleshooting.
Yeah, I can imagine chasing your tail looking at fabric settings or firewall rules when, someone just unplugged the wrong cable or a switch port died.
Happens all the time. Knowing link down points to the physical connection immediately tells you. Check the cables, check the interface status on both ends, check the switches in between. It narrows down the search dramatically.
Definitely saves time. Okay, one more deep dive here into diagnostics. Let's talk about one of the most detailed, maybe sometimes overwhelming tools,
Yeah.
the diagnose debug flow.
The debug flow. Yeah, it gives you a step-by-step look at packet processing.
Exactly, but the output can be pretty cryptic sometimes. What if you see a message and they're like, iPro check failed, drop. What's that telling you?
Right, that's a specific one. iPro check failed, drop. When you see that, it means the packet got dropped really early in the process, often before it even hit the main firewall policy evaluation engine.
Before policies, so what's checking it?
It's an internal FortiOS check. The two most likely reasons you'll see this specific drop message are: 1, the packet's source IP address is on an internal untrusted host list, maybe flagged by IPS or DOF protection earlier. Or 2, there's a misconfiguration related to an IP pool that the FortiGate needs to process the packet, perhaps for NAT or a specific policy.
An IP pool misconfiguration, like it can't find the right address to NAT2 or something.
Something like that, yes. Or the pool is defined incorrectly or exhausted. Basically, this iPro check failure signals a fundamental problem. Either the source itself is considered bad news by the FortiGate's internal state, or there's a core networking configuration issue, like with IP pools used in NAT or policies, that prevents the packet from even being properly processed further.
Wow. Okay, so that's not just a random drop. It's like the packet failed a very basic internal sanity check way before it got to the regular firewall rules.
Exactly. It tells you the problem isn't likely your firewall policy logic itself, but something more fundamental about the source of the traffic or a core config element like IP pools. It's a really valuable clue for those tough-to-diagnose issues where packets just seem to vanish.
That's fascinating. A very early rejection. So, thinking about all this, here's a final thought for you. How might understanding that very first point of failure, whether it's something as simple as a bad cable or a fundamental algorithm mismatch in VPN or an untrusted source triggering an early drop, how might focusing on that fundamentally change how you approach securing and troubleshooting any complex network, not just FortiGate?